from here on out, we are going to be just using derivatives in the process of our solving of the problems. And so today we're going to revisit that slope and equation of a tangent line, but this time instead of using the definition of the derivative where we took the long drawn-out process, we'll do the shortcuts. I'm actually going to start with problem number 2 because a derivative on a polynomial just uses the power rule and it goes fairly quickly. So f prime of x, because this is saying find the slope of the function at the given value. When I see slope, when it talks about slope, that tells me I'm looking at a derivative. So I'm going to find the derivative and then plug in the value. So my f prime of x is 3x squared minus 8x, and I'm looking for f prime of 3, which is 3 times 3 squared minus 8 times 3, and then it's just a matter of doing the math. 27 minus 24, my answer there actually is 3. So the slope of my tangent line, that is the slope at the given value. I jumped to problem number 2 because I want to, number 1 is a quotient, and normally we would think or jump in and do the quotient rule, but I'm actually going to do a different method here. Instead of using the quotient rule, I'm just going to tell you or show you another option at using a negative power, because I can, and it's not something that you have to do. You could go through and do the quotient rule on this problem. I just want to, again, show a different option. I could write this as f of x equals 3 times x squared minus 9 raised to the negative first power. The reason that I prefer to do it this way is because I think it goes quicker than doing a quotient rule, but that's not always an option. Every time you see a quotient, writing it as a negative power isn't going to make it easier necessarily to do. It's easier on this particular problem because the top is just a constant, and that's why I'm choosing to do it this way. So f prime of x is negative 1 times 3, so negative 3 times x squared minus 9 to the negative second power times 2x, applying the chain rule. Bring that down. Lower the power 1, inner as is, derivative of the inside. And so now I need to find f prime of 1. So that's negative 3 times x squared minus 9, times 1 squared minus 9 to the negative second times 2 times 1, which is negative 3 times, this would be 1 over 1 squared minus 9, so that'd be negative 8 squared times 2, which is negative 6 over 64, or negative 3/32 for my slope on that one. So I just, again, chose to rewrite it as a composite function, bringing that up to the top and making it negative 1, and then evaluating it that way. Again, you could have gone through and done the quotient rule if you wanted to, but I just wanted to show you that that's an option to do there for that problem. So again, that's my slope. The directions change on the next section, but what we do doesn't change at all. Finding the derivative at a given value is the same as finding the slope at a given value. The slope and the derivative mean the same thing. There are just different things that what we're doing is essentially the same for both of those, okay? So finding the derivative, you might hear this as differentiate. Finding the derivative, f prime of x. I know that this is a product, so I'm going to have to use the product rule. I will do the first times the derivative of the second plus the second times the derivative of the first. And then they're asking me at x equals 3. This should look very familiar, so I plug that in. This is negative 3 squared plus 5. 3 times 3 squared plus 6 times 3 plus 3 cubed plus 3 times 3 squared minus 2 times negative 2 times 3. And then it's just again a matter of evaluating. So negative 9 plus 5. The negative is not included in there. It's not parentheses around it, so I don't square the negative. It's going to remain negative. The 3 is the only part I square. And then this would be 27 plus 18. 45 plus, this next one is 27 plus 27 minus 2, that's 52, times negative 6. And again, I'm going to just continue to evaluate. This is negative 4 times 45 plus, I think that's negative 312, negative 180 minus 312 equals negative 492. It looks like is what I'm ending up with. It seems a little like a weird number, but the slope is a very steep negative. I'm going to go back and double check my work on that. In fact, I'll do that right now, and then we can meet back in just a little bit. Okay, yep, that is what I got. I just redid it and got the same thing. So again, slope of a function at a given value and the derivative of a function at a given value mean the same thing. So let's do another one with, or bring in some trig. Don't be worried about when you see the trig in there. Again, it just applies the chain rule. So f prime of x is, remember, sine is the outer, 3x is the inner. The derivative of sine is cosine, angle as is, times the derivative of the angle, and then I usually rewrite it, 3 cosine 3x. And I need to find the derivative when x is pi. So that's 3 times the cosine of 3 pi, and then I have to go back into my trig days, and I remember that's here. That's the point negative 1, 0. So the cosine of 3 pi is negative 1. This is 3 times negative 1, or negative 3. So my slope at that particular problem is negative 3. We're going to step it up now, not just finding the slope. We're going to find the equation of the tangent line. And again, we're going to be applying the derivative rules that we've been using. So when I work through a problem like number 5, for each problem, find the equation of the line tangent to the function at the given point. So I have my point. Remember, that's my x1, y1. And my answer should be in point slope form. Y minus y1 equals slope times x minus x1. Sometimes they want it in slope intercept form. This one says in point slope form, so I'm going to keep it in that form, which is easier, and thank you, because less work. Then I don't have to do any moving around. All I have to do is find the slope. Remember, the slope comes from finding the derivative at the given value, and then plug my x1, y1, and my slope into that formula. I can't do that thing I did this time. I shouldn't say that. I can do it. It's just not going to make it any easier as I did for problem number 1 earlier. So I'm just going to go ahead and do the quotient rule on this one. F prime of x is low d high minus high d low over low low. And I'm going to find the derivative at that x value. At negative 1 is where I'm interested, so I'll plug that in. This is 3 times negative 1 minus 3 times 2 times negative 1 minus negative 1 squared times 3 all over 3 times negative 1 minus 3 quantity squared. Getting a little bit ugly, but it's just a matter, all I'm doing is math here. So I'm going to end up with negative 6 times negative 2 minus 3 over negative 6 squared, which is 12 minus 3, or 9 over 36, which comes out to be 1/4. So I'll go ahead and put it all together. Y minus negative 1/6 is equal to the slope times x minus negative 1. And that's it. So no manipulating, no moving around, no getting it into slope-intercept form. I can just leave it in point-slope form. Let's do the same thing. This time again I have to apply another chain rule. F prime of x, I need the slope. Slope means find the derivative. This is 1/2 times negative 2x plus 2 raised to the negative 1/2, because I do the power minus 1, times the derivative of the inside, and I need to find this value at negative 1. Oops, at negative 1. So this is 1/2 times negative 2 times negative 1 plus 2 raised to the negative 1/2 times negative 2. I'm going to get that down on the bottom, that negative power, so this is equal to 1/2 times negative 2 over, that'd be 2 plus 2, 4 raised to the 1/2. Again, I'm just simplifying inside of there. Negative 1/2, I put it down on the bottom. Well, half means the square root. So what I have here is 1/2 of negative 2 is negative 1 over 2, because the square root of 4. So I multiplied the tops, took care of the bottom. That means my slope is negative 1/2. Then I'll go ahead and put it into my formula. Y minus y1 equals the slope, that's a negative 1/2, times x minus negative 1. Final answer, leave it in point slope form, call that one a day. On the back it looks like we have some of the same stuff. Just problems are maybe a little bit more difficult. So we're going to have some roots going on, some negative powers, things that we have to think about. So let's just kind of work through this. dy dx, same directions, find the slope at the given value. That's 1/3, 2x minus 4 to the negative 2/3, 1/3 minus 1, times 2, chain rule. Inside stays the same, derivative of the inside goes next. I'm going to do dy dx at x equals negative 2. Looks a little bit different how we write that. Instead of f prime of negative 2, I'll put it in dy dx at x equals negative 2. That's 1/3 times 2 times negative 2 minus 4 raised to the negative 2/3 times 2. You get 1/3 times negative 4 minus 4, that's negative 8 to the negative 2/3 times 2. So what I have here is, I'm going to just multiply these two together, 1/3 times 2. 2/3 times 1 over negative 8 to the positive 2/3. A little bit weird, but let's talk through that. That means I'm going to take the cube root of negative 8 squared. Usually when I have a problem like this, what I do is I will do the cube root part of it first if I can, and then square my answer. So I'll do the cube root of negative 8, which is negative 2. Negative 2 squared is 4. So I'm going to end up with 2/3 times 1/4 1/4. Simplify that down. 1/6 is my final answer on that particular problem. You can also, at any point, if you're plugging this in your calculator, just kind of plug it in. So I'm really more talking myself through it, not using a calculator to evaluate. I've got another one similar to that, another one with those powers, dy dx. Finding the slope at the given point means take the derivative 2/3 times 2x plus 4 to the negative 1/3. That again is 2/3 minus 1 times 2, derivative of the inside. I'm going to do dy dx at x equals negative 1. So 2/3 times 2 times negative 1 plus 4 to the negative 1/3 times 2. Again, I'm going to kind of move this stuff around and adjust. 2 times 2/3 is 4/3, so I'm just doing this piece and this piece, 4/3, got that. And then I'm going to multiply that by 2 times negative 1 is negative 2. Negative 2 plus 4 is positive 2, so that's positive 2 to the negative 1/3, or 4/3 times 1/2 to the 1/3. Well, that is the cube root of 2. So I'm going to rewrite that again. This is 4/3 times 1/, the cube root of 2. So when I'm simplifying this might be, it may have been a while since you've done stuff like this, I need to rationalize the denominator. Well, this is a cube root, so I need to have 3 2's in order to rationalize this denominator. So I'll do the cube root times 2 squared on the top and on the bottom. So I have 4 times 1 times the cube root of 4, because that's what 2 squared is, over 3 times, my whole point in doing this is to get that out of that radical. Well, then I can simplify here. My final answer is 2 times the cube root of 2 squared, which is 4, sorry, I almost wrote that as 2 again, over 3. Pretty ugly answer, but that's fine. Like I said, some of these are just a little bit more challenging. Same directions, just a little bit more of a challenge to it. Speaking of challenge, we're going to do an equation of a line. This time it's going to be in slope-intercept form. So slope-intercept form, remember, is the y equals mx plus b form, but I'm still going to use the y minus y1 equals slope times x minus x1 to get into that form. But ultimately my answer needs to be in that final form. So again, what do? I have to jump in and do my derivative because I need to find the slope. So the slope dy dx is negative 1/2 times 3x plus 6 to the negative 1/2 times 3. That 3 comes from the derivative of the inside. I'm going to evaluate this dy dx at x equals 1. So I will put that in there. 3 times 1 plus 6 to the negative 1/2. I know that's eventually going to end up in the denominator. Times 3. Keep working here. I'm just continuing to do my math. Negative 1/2. Let's multiply these two together. So that's negative 3 halves times 3 plus 6 is 9 to the negative 1/2. Well, that is negative 3 halves times 1/9 to the 1/2, which remember is the square root of 9. And so I have negative 3 halves times 1/, the square root of 9 is 3. Do some canceling. My final answer is negative 1/2. That is my slope. That's the m part of it. It already feels like I've done a ton, but I am only here. Now I also have a little bit of a different problem for this one because they only gave me the x value. And I need an x and a y to use my point slope form. So I found the slope. Now I need to go ahead and find the point. So I'm going to evaluate, I'll do this in a different color so it kind of stands out, but I'm going to evaluate y at x equals 1, and so that is the opposite of 3 times 1 plus 6 to the 1/2 power, which is the opposite of 9 to the 1/2 power, which is the opposite of the square root of 9, so that's -3. So the point that I'm going to be using is 1 comma -3. Now I have my slope, I have my point. I'm going to put it together in my point-slope form. So this is y minus -3 equals -1/2 times x minus 1. But because the directions said put it in slope-intercept form, now I'm going to have to manipulate this. So I'll distribute that through. Y plus 3 equals -1/2 x plus 1/2. Minus 3 minus 3. Y equals -1/2 x. 1/2 minus 3, that's 1/2 minus 6/2. So minus 5/2, final answer. Same stuff, just a little bit more work on this problem. Again, pause it and soak it in if you need to. Let's jump into our next one, which is a trig value, but same concept, same thing. I need the point and the slope. On this particular problem, maybe I'm going to start by finding the point. I have to find a point and a slope. The point is the value. I've got the x part of it. So I want to find y when x equals pi, and so this is the sine of 2 pi when I plug that in. Well, the sine of 2 pi is 0. Remember, that's right here. That's the point 1 comma 0. The sine is 0. So the point that I'm going to be using is pi comma 0. Now I need the slope. And remember, the slope comes from the derivative. So I'll go ahead and I'll do the derivative. dy dx equals, the derivative of sine is cosine 2x times 2. So dy dx is 2 cosine 2x. I need to evaluate that at pi. dy dx when x is pi is 2 cosine 2 pi. Well, cosine is 1 from back here. Cosine is 1. So this is 2 times 1, or 2. Again, here is my point. Here is my slope. Don't know what I spelled there. And I'll put it into the form of the equation. Y minus y equals the slope times x minus the x. Y equals 2x minus 2 pi, and now I'm in slope-intercept form. All right? So it's just using the derivatives and then doing some evaluating. As always, if you have any questions, ask, but your job is to do 10-3 homework, evens or odds.